All right. When we write solutions to inequalities, we're going to use interval notation most of the time. So if it doesn't tell you a notation to use interval. We will also talk about set notation. So those are just ways to present your answer. So for example, x is greater than or equal to 3. Okay, so we use a bracket to include the 3. And then greater than or equal to 3, that means it can be anything bigger than 3, so all the way up to, we just say positive infinity. So infinity is not technically a number, it's really just more of a way, a symbol to represent that they go on and on and on forever. So we can't include infinity, so we use parentheses. So we always use parentheses when we're talking about negative or positive infinity. We'll also use parentheses if there's not a equal to sign. So if we're not including it, we'll also use parentheses there as well. So for -5 less than x less than or equal to 3, this is a compound inequality because I have two inequality signs. We want to graph it and then write the solution in interval notation. It's easier to graph it first because that describes the interval that I need to write. Okay, so when you have to graph these on number lines, I don't need to see every single little mark like -10 to +10 or anything like that. Just really basic. Use 0 as like a placeholder, so I'm just going to put 0 in, and then -5, okay, that's left of 0, +3, that's right. Okay, so that's all I need to see. So 0 is not really doesn't really have anything to do with my solution. It just tells me, okay, if this is where 0 is, -5 would be left of it, +3 would be right of it. Okay. So when I read these inequalities, I always read from the variable. So x is greater than -5 and less than or equal to 3. So x is greater than -5, x is less than or equal to 3. All right, so that is saying x is in between those two numbers. So here's where I'm shaded. Now, before when you did this, you would use open and closed circles. So instead of doing open and closed circles, we're going to use bracket and parentheses, just because that's what we'll have to do in the interval anyway. So at -5, am I including the -5? No, there's not an equal to, so I use parentheses. What about 3? Am I including the 3? Yes, because there's an equal to, so I use a bracket. All right, well, that's the interval then. That's the interval that I want to write. So my interval describes what's shaded. So we say x is an element of, because x is any number in that set. So in that interval. And it goes from -5, so parentheses -5, comma, 3, bracket. That is the interval where my solution is. This is the variable x. So if this had been like a or y or something, you would use that here. Okay, questions about that? Okay, so we're going to talk about just some basic solving here, basic inequalities, just single inequalities, not compound. So these follow the basic rules for solving equations, meaning you're trying to get the variable by itself. The only exception is if you multiply or divide by a negative, you have to reverse the sign of your the direction of your inequality. So you change the direction. Okay? So the solving here is not too hard. I want to get x by itself, so what should I do? Divide by -3, but since I'm dividing by a negative, I need to switch the sign. -12 divided by -3 is +4. Okay. Let's go ahead and graph and then write our answer in interval notation, and then I will also show you set notation. Alright, so I'm going to use 0 as a placeholder. 4 is right of 0. When I say x is greater than 4, should I shade left or right of 4? Right. You can think of your inequality as long as x is on the left. You can think of your inequality like an arrow. So I'm pointing to the right. So I'm shading right of 4. Am I including 4? So would I use bracket or parentheses? Parentheses. So that's the interval that I need to write. So x is my variable. You always write your intervals from least to greatest. So I'm starting at 4, but I'm not including it. So parentheses 4, comma. And then where am I ending? Positive infinity. That's why I have that arrow shaded in here at the right. So positive infinity, and always parentheses around infinity. Okay, so here's one answer. Let's talk about set notation. So set notation isn't something we use all the time. We definitely use interval notation more. But set notation, we talked about this a little bit in our last chapter because we used the braces. And then we also use that vertical bar that means such that. All right, so you have to state what your variable is. So the variable I'm using here is x. So I have x such that. So all of these will start off the same way. X such that, or a such that, whatever your variable is. So they all look like this. And then you just put your solution. So it's saying we're taking all x such that x is greater than 4. So this goes here. So really, set notation is a little bit easier to write because you don't have to think about the interval or the number line. But we don't use it as much, so sometimes it can be harder because we just don't use it very much. But all you do is you put your solution in it. So. Okay? All right, let's look at another one. It says to solve and write the answer in set notation and interval notation. So if it doesn't tell you what notation, use interval. If it wants set notation, it will specifically say set notation. If it wants both, it'll say both. Okay, so I'm solving this like I would with an equation, so I have to distribute to get rid of the parentheses. And then I want to combine like terms. So 10 minus 3 was 7. With inequalities, put your variable on the left. So I know you can add 5x to the right side, but then you're reading it backwards and your graph might end up being backwards. So just to avoid that, go ahead and just move your, if possible, always move your variables to the left side. So I'm going to subtract 3x.
Excuse me, Ms. Cecil, could you please send Alyssa Felix to check out of attendance?
Yes.
Thank you.
Okay, so -5 minus 3 is -8. And I need to subtract 7 from both sides. And I'm dividing by -8, so I'm dividing by a negative number. I need to switch my sign, don't forget. And that's -1/2. Okay. So my interval, let me graph it on a number line first. So 0, -1/2. X is greater than -1/2. So when I shade left or right, I would shade to the right. And would I include -1/2? No, so bracket or parentheses. Okay, so my interval notation. So x is in the interval from -1/2 to positive infinity and bracket or parentheses. Okay. Set notation. So x such that. Then what would I write? X is greater than -1. Yep. So solving is not your final answer. Okay, this is not the answer. Either using interval notation or set notation is a final answer. This is how you would describe your solution. Questions about that? Okay, let's go through a couple more. This says write the answers in interval notation where appropriate. We're not doing set notation here. I have to simplify each side, so I have to distribute combined like terms. On the left, -3 and 30 are like terms. That's 27. On the right, 14 and 1 are like terms. So that's 15. I want to get my variables on one side, so I'm going to move the -6 on the right to the left. Okay. So just like equations, sometimes you have special cases where the variables cancel on both sides. Again, we're looking for true or false statements. Now, with equations, to be equal, they have to be the exact same. Inequalities don't necessarily have to be the exact same to be true. So you read the inequality. Is 27 less than or equal to 15? No, that's false. So that's no solution. the line through it. Yeah. I wouldn't take off points on this one if you write no solution, because this technically isn't an interval either. So I would take it. Yes. Yeah, so no solution is, if you get a true or a false statement, then there is not a solution. I mean, that's why this makes sense here. There's not a solution that would make this true. No matter what you plugged in for x, you would not get a true statement. Undefined is the word to describe when you divide by 0. Okay, so if you ever have to divide by 0, that value is undefined. Yeah. What would I prefer? Probably this, the empty set. I mean, that's shorter to write. So, and that kind of shows you know what that means, but I would accept either one. Okay. So this one, I need to distribute the negative. And I distribute the negative on the right as well. I need to combine like terms. So on the left, 8 and negative 6 are like terms. On the right, negative 9m and negative 3m are like terms. Oh, but that, it should be plus 4m, thank you. Yeah. I wrote that. Okay. Negative 3 plus 4m. So it's the negative 9m and the 4m that are like terms. Thank you. Negative 5m. I want to add 5m to the left. Again, they're both canceling. So I have to see if I get a true or a false statement. So 2 is not equal to negative 3. So if this were an equation, this would be no solution. But that's not what it's saying. It's saying 2 is greater than negative 3. Is that true or false? True. So as an inequality, this is true. This is all real numbers. So we said, x is an element of the reals. Now there is a way to write this in interval notation. So we have to get used to that. So to say x can be any number, that would be like your whole number line shaded. So what does this left arrow represent? Negative infinity. What does the right arrow represent? Positive infinity. Okay, so you do have, if it says interval notation, you have to write this as an interval. X can be any number. Okay, because this is true, that means no matter what I plug in for, m, no matter what I plug in for m, I get a true statement. So m can be any number. And that's why it's saying it can be any real number. That's what this says here. And then this is how to write that as an interval. Yeah.
Do you have to do the number line?
No, you don't have to do, you don't ever have to write a number line unless it says to write a number line.
Okay.
But doing the number line makes writing the interval easier. There are some times like some weird ones, and especially next week when we start doing absolute value inequalities, that the number line is going to be really helpful for you to write the interval. Okay, but if it says graph it on a number line, you have to do the number line. Okay. All right. So those are some special cases of single inequalities. We're going to start talking about compound inequalities. Sometimes these are called joint inequalities. because it's more than one inequality that's together. So you have more than one inequality sign. So that's how you know it's a compact. Yes. The parentheses, yes, is the one that does not have the equal to. Bracket has the equal to. Okay, so we've already looked at this first one. We've graphed it. So as an interval, we have this. X is an element from -5 to 3. So when X is in between like this, that is saying and. That's just a shorthand way to write and compound inequalities. Just a shorter way. Because if it's and, then it has to be true for both, which means it has to be in between. So it has to be greater than -5 and less than or equal to 3. So it has to be somewhere in this interval. It has to be in between. It has to be true for both. So if it's or, then it's either or. So if you're looking at these two symbols, the union is the or one that we'll use. That means both sets together. This upside down, so it's kind of like a YU, and then you flip it upside down, that means intersection. So that would have to be true for both. That's the overlap. We really won't use this intersection symbol very much because when we're using and, then it's between two numbers. So we don't need to really use the intersection symbol. We will use union though. So when we talk about or, so let me graph again so we can get a picture of what the intervals are. So we have 0, 5, and 8. I'm greater than or equal to 8, so that's right of 8. And bracket or parentheses. Bracket. And then I'm less than or equal to 5, so I'm less of 5. And again, a bracket. It's or, so we're okay. I can have a number either over here, so less of 5, or over here, right of 8. So when I'm writing this in interval notation, I have two intervals. I have my first interval, which is -infinity to 5. But I also need to include this interval, 8 to positive infinity. So since I'm connecting those two intervals together, I have to use the union symbol. So you will use the union symbol, really won't use the intersection symbol. Very rare cases you would need to use that. Okay. When it's an or, you'll have two separate inequalities, so just solve each one separately, and then you'll graph them on the same number line and write their intervals together. for this one, all I have to do is add 3. Okay, so I have x is less than -7 or x is greater than or equal to 2. It says graph the solution, so we have to graph anyway. Remember, this is just solving. This is not writing my answer yet, so I have to use interval notation. It doesn't tell me a notation, so I'm using interval notation. Now let's graph first. So -7, 2. Okay, x is less than -7. Do I shade left or right? Left. Would I have a bracket or parentheses at -7? Good. X is greater than or equal to 2. Would I shade left or right? Would I have bracket or parentheses? Bracket. Good. So my interval, okay, I have this first one, so it's always the least to greatest. You'd always start left and go right. So the very least amount I have is -infinity up to -7 parentheses. And then I need to tie that to the other interval, so I have to use the union sign. And then bracket 2 to positive infinity. Questions about that? Good. Okay. A lot of times the and inequalities, compound inequalities, will be written in that shorthand way, but every once in a while it will have and written out for you. If it's an or problem, it'll have the word or. There's not a shorthand way to write or. But the ands can have that x in between, or it can have the word and. So if it has the word and, you're still doing the same thing you did with the ors. You want to solve each one separately. So subtract 5 and divide by -3. I divided by a negative, so I have to switch the sign. Here I'm just dividing by 5. What's 0 divided by 5? 0. Okay. 0 is a fine answer. It's still 0 is a real number, so that's okay. We get 0. All right, this time though in my graph, since I need and, I need where they overlap. I need both. I need it to be true for both. So when I'm going to graph this, I have my 0 and -4. So greater than or equal to -4 is this to the right, okay? Less than or equal to 0 is to the left. So where is it going to be true for both? In between. So I only want to shade right here. So either erase the shading out here or darken in the shading that it needs to be. At -4, would I have bracket or parentheses? And 0, bracket. So then I only do an interval over what's shaded, and in this case, the overlap. So my interval is just from -4 to 0. I don't have -infinity. I just go from -4 to 0. I want to do another example. It's a short one. Okay, so this is also an and. I know it's and because I have x in between these two inequality signs. So if it's an and, it's not always going to say and. It could be written like this. So what they did was, to do this is you shorten this basically. So I have two inequalities written as one. So when I go to solve, I'm just going to try to get x by itself in the middle. I'm going to keep it in the middle. I want to subtract 3, but I can't just subtract 3 from the two sides. I have to subtract it from all three sides. Okay, you've done this before when you solve these back in Algebra 1, but let's just talk about it again. So I get negative 8 less than or equal to 2x less than or equal to 4. Then what do I get to do? Divide by 2. And again, all three sides have to be divided by 2. Okay. So you have x is between negative 2 and 4. So expose brackets. If we were graphing that, so when you graph, you always read from your variable x is greater than or equal to negative 4, so that's right of negative 4, but it's and less than or equal to 2, so that's left. So they overlap right here. Both have brackets. Okay? Questions about that one? This one's already solved. It just wants us to graph and then state the solution in interval notation. It's an and. Okay, x is greater than or equal to negative 5. So which way is that telling me I have to shape? Right. Okay. And I would have a bracket. X is less than negative 7. Which way is that telling me I need to shape? Left. And I would have a parenthesis. But this says and. So that means it has to be true for both. That means it has to be where they overlap. So can you think of any number that is greater than or equal to negative 5 and less than negative 7? No, there's no overlap. So because it's and, it's no solution. Right? If it says or, we'd be fine. Because it could be either or. But because it's and, it has to be where they overlap. So it's no solution. Okay, one more thing that I want to talk about. Don't feel like you need to write all of these sets down. We're only going to compare A and C. So if you're wanting to write this in your notes, you want to write A and C down. We're just going to briefly talk about union and intersection, but it's pretty easy. You just have to remember which one is which. So if you want to do the intersection, then that's where they overlap. That's the and. So that has to be where they overlap. So the numbers that they have in common. So the intersection of A and C are the ones they have in common. Okay, so we're going to write these least to greatest. -2. What else? Okay. 2. And is that it? Any other numbers that they have in common? Okay, so -2, 0, and 2. That's the intersection. Union means both sets join together. So you're including all the numbers. You're not going to write them multiple times. So the ones they have in common, you're not going to write those twice. But you're including all the numbers from both sets. Let's go least to greatest. So -4 and -3, -2, -1, 0. 1, 2, 3, 4. That's all the numbers from both sets.